Okay, is it visible to all? Okay. So we have started with the gastrointestinal agent. That will be your unit number 3. So basically your gastrointestinal system include a set of organs starting from mouth to anus. This involve the major task of digestion. And in this, you can see you are having stomach, mainly esophagus, pancreas, small intestine, large intestine, and the agent which are working on the gastrointestinal system. Majorly, these are from inorganic sources. These are broadly classified into 4 categories: acidifying agent or acidifiers, antacids, protectives, and adsorbents. Lastly, cathartic, laxative, and purgatives. These acidifiers will be used in the condition of achlorhydria where less amount of acid will be secreted. Antacids will be used in the case of hyperchlorhydria where it will be neutralizing the excess of gastric acid. Protective will be protecting from the ulcer and inflammation. Adsorbent will be absorbing the toxin in case of diarrhea, dysentery, or microorganism. Cathartics and laxatives are used in the constipation. So if we first see this acidifier, majorly these are classified into 3 category: systemic, gastric, and urinary. Systemic acidifiers will be used for restoring the overall system pH, your blood and circulatory system. So systemic pH will be on the alkaline side, and if I am using systemic acidifier, the pH will be normalized. Gastric acidifiers will be used in case of achlorhydria or hypochlorhydria where your gastric acid secretion amount will be less. Urinary acidifiers will be used to render the urinary system pH on the acidic side, and it may be the case of urinary tract infection or urinary calculi to be dissolved, stone to be dissolved in the urinary tract. So these are the major class of acidifier, and we will be discussing the gastric acidifier. So inorganic chemical or drug which are used to increase the gastrointestinal acidity. So the drug which is increasing the acidity of the gastrointestinal system. Okay. In case of chronic gastritis, gastrectomy, carcinoma of the stomach, this may be the condition where the less amount of gastric acid will be secreted, and for the temporary arrangement you are providing externally a acidifier. Various acidifiers can be used, and we will take the example of dilute hydrochloric acid. It will be acidifying the food and it will be stopping the action of salivary amylase. It will provide the acidic medium for the food digestion. Okay, it also kills the microorganism. And here you can see the monograph of dilute hydrochloric acid. How much dilute it is? It is 10 percentage. Okay, it is given as a weight by weight. Okay, the formula is given in the weight. You are taking concentrated hydrochloric acid in 274 gram. You are adding additional water and doing total 1000 gram. So this is how you are diluting. And if you can see the limits, the practical standards are 9.5 to 10.5 percentage is allowed. It is a clearless liquid. Sorry, it is a clear liquid, colorless liquid. It is strongly acidic and has about 1.04 to 1.05. That is almost 1 specific gravity or density, you can say. Taste for purity, it has to be tested for certain heavy metals and impurity. It can be used as an acidifier. Major uses as an acidifier. If you will observe the assay procedure, it is acid. So, but obvious, you are going to use acid base titration for this. And if you can see, hydrochloric acid, it will be titrated with a base, and that is sodium hydroxide using methyl red as an indicator. Okay, and you can see the factor, like using factor, you can calculate the strength of HCl. Dose will be 0.6 to 8 ml. Okay, now the second category, what we have learned, this is antacids. Antacids are the drug which are alkaline substance used for neutralizing excess of gastric acid, which is associated with the ulceration, gastritis, and peptic ulcer. Means if the acid is in more amount, it can cause some effect like ulcer production, inflammation, that is gastritis, and it can lead to ulcer. So that is why we are neutralizing the excess of gastric acid in the patient who is suffering from hyperchlorhydria. Okay, so these antacids are usually weak alkaline substances. It will raise the pH of the stomach and it will be neutralizing the excess of gastric acid. Then we had the ideal characteristics of antacids. So, what are the characteristics? It should not be absorbable or cause systemic alkalosis. Once it will be absorbed, it can cause systemic alkalosis. So, systemic alkalosis is the condition where the pH of your system will be on the alkaline side. It should not liberate the carbon dioxide or cause rebound hyperacidity. Simply, we can say it should not produce large amount of gas by the reaction with the gastric acid. Say, suppose calcium carbonate and HCl. Calcium carbonate will be converted to calcium chloride, and excess of a reaction will be involving carbon dioxide formation. So this gas should not be liberated. It should not interfere with the absorption of the food. Okay. It should not be having any side effect like laxative, or it should not cause constipation. It should be rapid in the action, and it should also give the effect for the longer period of time, because gastric acid secretion process is quite continuous. It should buffer in the pH range of 4 to 6. Okay. It should be not inhibiting any digestive enzyme, and it should be readily available to the stores or OTC product. You can say it should be palatable, means it should be acceptable by the patient. It should be readily available. This can be classified into two major categories: systemic antacid and non-systemic antacid. Systemic, which is having ability to be absorbed and cause the overall systemic pH on the alkaline side, that is systemic alkalosis, can be possible if you are consuming a lot amount of systemic antacid. So simply it should be soluble in water, and we are having one example which is soluble, that is sodium bicarbonate. Okay, it is water soluble, it goes to systemic circulation, and it can uh, produce the side effect of systemic alkalosis. It can cause systemic alkalosis, if you can see. Then another class we are having, that is non-systemic. So definitely these are not soluble in water. It is not soluble in water. It won't be absorbed from the stomach also, and it won't be having that side effect of systemic alkalosis. Okay. Then it is classified further depending on the salt type, either aluminium containing or calcium containing, or it can be a magnesium containing antacids. So aluminum hydroxide gel, dried aluminum hydroxide gel, these are the example. Additionally, aluminum carbonate, phosphate, glycinate can be there. Calcium carbonate, calcium phosphate, calcium containing antacid, magnesium carbonate, magnesium hydroxide, and even magnesium oxide can act as an magnesium containing antacids. Now let us focus on the monographs of the antacids, sodium bicarbonate. So as you are knowing, this is a systemic antacid. Commonly we are knowing this compound as an baking soda. And if you will observe the standard, it should contain 99 to 100.5 percentage of the sodium bicarbonate. Okay, how you can prepare this? Simply you can have this reaction. You are passing carbon dioxide gas from the solution of the sodium hydroxide. It will be forming temporary sodium carbonate, and then again the reaction continues and it forms sodium bicarbonate. Okay, the compound of our interest. It is soluble in water, crystalline, then it gives effervescence with the acid, and it is also used in the effervescent mixtures like Eno, what we are having in the Indian market, right? Identification taste. It can give characteristic reaction of the bicarbonate, that formation of gas with the acid. Taste for purity, it has to be tested for alkalinity, aluminum, calcium, and other heavy metals. If you will see the acid procedure, you can go for the acid base titration. It is a base and it will be reacting with the acid. So what acid we are taking? We are taking sulfuric acid. So no more complication is there in the acid procedure. Simple acid and a base using a indicator. So this will be the possible reaction of the assay. Then you will be calculating the amount based on the factor. This is about sodium bicarbonate. It will be mainly used as an antacid. It can also be used in the systemic acidosis, vice versa. This can cause systemic alkalosis, so it can be employed in the systemic acidosis. Okay. Now, second monograph, what we are learning is a aluminum hydroxide gel. If you will focus on the word gel, then what I will be thinking for this gel is something like suspension, which is having some viscous liquid. Okay, viscous liquid means something gel, I will be assuming here. And it is a suspension, viscous suspension, which involve aluminum oxide. This preparation contains not less than 3.5 percentage and not more than 4.4 percentage of aluminum oxide. This will be the standard. How you can prepare this? You are not making suspension of aluminum oxide, but you are having a reaction that will be forming aluminum hydroxide. Okay. So you are taking hot solution of potash alum. You are using sodium carbonate solution and potash alum solution, and you will get the precipitate of aluminum hydroxide. Then we will collect this precipitate. We will wash it with the water to remove the sulfate impurity. Wash with the hot water and then collect the precipitate again, redisperse in the water, and this will be suspended in water, forming the suspension. As the precipitate will be gelatinous, viscous, so it will be easy to form suspension. That is why we are having this in situ reaction, where we are having chemical reaction during the manufacturing. Okay. Properties: it is a viscous suspension. It will give you the characteristic reaction of aluminum. It can form aluminum chloride with the acid, and this will be having some astringent action, and it can cause constipation too. Okay. Assay will be performed by complexometric titration. It is not directly soluble in water. You will use hydrochloric acid to make the solution of aluminum hydroxide gel. Okay, then we are neutralizing the excess of acid by adding a base. Then we are adding hexamine, and you are back titrating with the lead nitrate. So initially you are adding disodium EDTA, that will be forming a complex with the aluminum. and unreacted EDTA, disodium EDTA, which will be reacting with the lead nitrate, will give you the color change. So this is a back titration, complexometric titration. Okay. And finally, you will have a factor that we will be using for the amount calculation. It is used as a slow acting antacid. So if I wish to have a good antacid, I can mix something that is rapid in action with the aluminum hydroxide gel. So I will be having rapid onset as well as I will be having the effect for longer period of time. Okay, so this is why we are combining the multiple antacids in many of the times. Dose, if you will see, this is 7.5 ml to 15 ml. It can cause constipation, therefore it is administered along with the magnesium salt, okay, which is a mild laxative. Next monograph is magnesium hydroxide mixture. We are revising this. Okay, do remember that is why we are moving little faster. So we are learning this magnesium hydroxide monograph. Okay, it is also known as milk of magnesia or milk of magnum, or it is also known as magnesium hydroxide mixture. So here you can see how we can prepare. Again, you are having a similar preparation than that of the aluminum hydroxide gel. You are having sodium hydroxide and the magnesium sulfate. And what we need? We need magnesium oxide, hydroxide. Okay, which will be mixed with the magnesium oxide to make the suspension. So reaction is like your sodium hydroxide and magnesium sulfate will be forming magnesium hydroxide precipitate. Again, you need to wash off this sodium sulfate. You will be washing off the sodium sulfate till it becomes free, and then you will collect the precipitate, then disperse in the water, and this will be your suspension, your white colored suspension. That is why it is termed as a milk. Okay, this preparation is majorly used as an antacid, one of the old preparation, traditional preparation that still it is there in some market. In Western countries, it is still available as a OTC product. It is normally packed into blue colored bottle. So blue color container will be there. If you will search on Google some milk of magnesia products, it is a white creamy suspension you can see. And if you will dry this, you will get the powder also. Fine. How you can identify? You can dissolve this into the dilute acid, then it will give you the characteristic reaction of magnesium. If you will see the assay procedure, it is again a back titration method where you will be using methyl red as an indicator. Okay, now what we are doing, you are adding, you are taking the sample, then you are dissolving in acid. So your antacid will be reacting with the acid, and whatever the acid which is remaining, which is not reacted, which is unreacted portion of the acid, and this acid will be reacting with the base what we are titrating with. So we are titrating it with sodium hydroxide using methyl red as an indicator. So this is how we are doing titration. So it will be titrated with the NaOH by back titration method, and you can calculate the amount from the factor. It can be used as an antacid. It can be used as a laxative. As you guys are knowing this, all the calcium containing and aluminum containing antacids are having side effect of constipation, and magnesium containing antacids are having side effect of diarrhea, or it is having laxative effect. That is why if you are going to use it in a larger dose, it will be acting as a laxative. So you need to use it in a small dose for antacid. Okay. Label can be shake well before use, as it is a suspension. In all the suspension, the particles may settle down. That is why we are using this shake well before use label. Now we are using this next monograph, which is antacid calcium carbonate. It can be termed as a precipitated chalk. Okay, it is having not less than 98 percentage and not more than 100.5 percentage of calcium carbonate, which is calculated with reference to the drying. Okay, it can be prepared by a simple reaction. You are taking sodium carbonate from where the carbonate will be coming, and you are taking calcium chloride from calcium will be coming. So calcium carbonate, and remaining part will be the sodium chloride. Similarly, you can prepare the calcium carbonate from the calcium hydroxide, where you will be passing the carbon dioxide gas. Okay, so lime water turns milky. This was a one taste for the chemistry, what you were learning in your high school chemistry. So same process can be used to generate calcium carbonate. Okay. Even similar reaction with the sodium carbonate can be done by calcium nitrate. Property, it is a fine white microcrystalline powder. Now what do I mean by microcrystalline? So crystals are even too small that sometimes it feels like it is a amorphous, or it is a crystalline. So it is in between, like microcrystalline powder. Odorless, tasteless. It is, remember, it is not soluble in water. That is why it is a non-systemic antacid. It is not soluble in alcohol. It can be soluble in dilute mineral acid. That is why for the assay we will be using the same procedure. Okay. It will give you the characteristic reaction of calcium and carbonate for what? For identification purpose. Assay will be performed by complexometric titration, where you are making a solution with the HCl. You will use HCl to make solution, then you are adding some water in the sample. Okay. Then excess of acid will be neutralized with the NaOH, and we need alkaline pH for the reaction. So we are also adding this murexide and naphthol green for the color change. And finally, it will be titrated with the 0.05 molar disodium EDTA. Then you will calculate the amount by using the factors which is provided. It is used as a antacid. Okay. Now one of the equation that we has discussed, combination of antacid. Why we are preparing combination of antacids? Okay, so one reason is some of the antacids are having side effect of constipation, and some are having laxative effect. To combine both of the effect, or we can say to neutralize both of the effect, we are combining calcium and aluminum containing antacid with the magnesium containing antacid. Like some of the antacid are slow acting antacid, like aluminum hydroxide gel, and bicarbonate is rapid acting. So we can have a in between combination that have rapid onset of action, means it will start working quickly and it will work for longer time. So second reason is this. And some may have systemic alkalosis, some may produce hypercalcemia. If you're using a lot of calcium salts, or you can say calcium compounds, it can produce hypercalcemia. Okay, high concentration of calcium in the blood. That is why we are keeping multiple ions, or we can say multiple components in the antacid. Antacid may also have side effect like gas formation. The calcium carbonate neutralizes the HCl and CO2 will be released. In many of the cases, gas may release. So you can add something like simethicone, that is an antiflatulent agent, which will be used if the antacid is causing discomfort due to the gas formation. So this will be going in the mixture, and this is why we are having combinations of antacid. Okay. Sometime you can have some other ingredients too in your antacid preparations. Okay. So everyone,